Okay, we're starting Module 6, Lesson 2 today, and it is more work with the coordinate plane. It kind of builds off of Lesson 1. We're going to learn quite a bit of vocabulary, how to plot points, how to graph lines. So some of it will be a review of Lesson 1, a lot of it will be new. So this coordinate plane is called the rectangular coordinate system. And we can plot points on the coordinate plane by finding the x value, because a coordinate plane is made of two intersecting axes, as we learned in lesson 1. The horizontal axis is x, the vertical axis is y. And we can plot points by finding the x value, finding the y value, and finding where they meet and draw a point. Or plot a point is what the correct vocabulary is. So the coordinate plane, like I said, is made up of a horizontal axis and a vertical axis, and that divides it into 4 quadrants. Quadrant 1 is what we worked with mostly in lesson 1 when we were drawing the graphs for the telephone company, or the different plans for the telephone bills. But the plane is actually made up of 4 quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. So keep in mind they do go counterclockwise, because students want to do this 1, 2, 3, 4. Nope. Start with all the positives, because that's where most of the word problems are, in the positives. That's what we call quadrant 1, and then go around counterclockwise. And notice the quadrants are also labeled with Roman numerals, 1, 2, 3, and then IV means 5 minus 1, which is quadrant 4, because V is 5. The 1 in front means take 1 away. So let's practice plotting these. So not only are we going to plot the points, we're going to determine what quadrant they're in. So for this first one, we're finding -4 on the x. Remember, points are always in alphabetical order, like listed above, x, comma, y. So we find -4 on the x-axis and +6 on the y-axis. And I need more light here. And where they meet is where we plot our first point. So -4, 6 would be right there. So x is -4, and then on the y-axis +6, and we either label each point with its coordinates, or we can label it with the capital letter. So in this case, it's a little bit easier to do the capital letter. And we know the quadrants go 1, 2, 3, 4, so this would be in quadrant 2. Next, we have +6 and -4. So where they come together, we plot a point. +6, -4 would be right there. And that we will call point B. And that is in quadrant 1, 2, 3, 4. IV is 4. 3, 5, 3 on the x-axis, 5 on the y-axis. They come together right here. And that will be quadrant C. Oh, quadrant C. Oh dear, Kim. It's late. I shouldn't be making videos at 11 at night, should I? So x is 3, y is 5. That point is called C, and that will be in quadrant 1. Quadrant 1's always easy to identify because it's where all the x's and y's are positive. That's why most of our word problems occur in this, because time is usually positive, amount of a telephone bill is positive. So most of our word problems are in quadrant 1. Okay, -1 and then down -2.5 would be right in between -2 and -3. So at -1, that tells me to go down 2.5, and that will be point D. And that would be 1, 2, 3. quadrant 3. And then E is x is 0, y is -5. Whenever the point lies on an axis, we can't state the quadrant. So what we do is we say what axis it is, because this is in between quadrant 3 and quadrant 4. So we would say y-axis. And you'll notice, and we'll learn this in more detail as this class continues, every time a point is on the y-axis, it's called the y-intercept. And when you have a point on the y-axis or the y-intercept, x is always 0. Likewise, when y is 0, it's called the x-intercept, and it will lie on the x-axis. So we find -5.5 on the x-axis, and then it says 0. So that means we don't go up or down. We just plot a point in between -5 and -6. And again, that one is not in a quadrant. It's in between quadrant 2 and 3. So we just say x-axis. And last but not least, 3 1/3 would be a little bit after 3. So I'm just going to put a little, because it's like 3.3, so about right there. Not at a half, just a little left of a half. And then down 2 1/2. And down 1 2 1/2 would be right there. So +3, whoops, yep, I didn't quite make it over enough. So +3 1/3 down 2 1/2, that would be called point G, and that would be in 1 2 3 quadrant 4, IB. And notice the quadrants have something in common. Whenever the first coordinate's positive and the second coordinate's negative, it'll always be positive. It'll always be quadrant 4. Whenever both coordinates are positive, it will be quadrant 1. Whenever the x is negative and the y is positive, that will be quadrant 2. And then quadrant 3 has when they're both negative is when we'll be in quadrant 3. So that's a little practice with graphing. So just always remember the first coordinate is on the x-axis, -4. The second coordinate's on the y. So then that says go up to 6 on the y, place a point. Next, we're going to practice giving the ordered pairs, and we can also practice with the quadrants on this if get some additional practice in. So point R, and this graph isn't very dark, is it? So it looks like it's -6 and up to +6. So we always write what the x value is first. The x value is -6. The y value is +6. And they must be in alphabetical order, x, comma, y. And that would be quadrant 2. S is x is 5. Y, we didn't go up at all or down. So that means it's 0. So that would be 5 0. And remember how I said every point on the x-axis has y equals 0. And it's called the x-intercept. And so this one we would just say x-axis. T would be -3 on the x. And then we go down to, that's about a half. It could be a third, but we'll just say a half for our purposes. I guess I could make it bigger and look closer. So -3, yeah, I think -4.5 would be good for that. So -3, -4.5. So x is -3, y is -4.5. So -3, -4.5, and that would be in quadrant 1, 2, 3. And then u is on the y-axis, and it looks like it's at, let's make it big again. Yeah, I guess that's close to negative 9.5, right? So then we have to say what's x? X is 0 and y is negative 9.5. So 0, negative 9.5. And that would be y-axis, and we know the y-axis always has x0. It's called the y-intercept, and it'll always have x as 0. Okay, let me adjust the screen before we go to the next page. So there's our practice with graphing. There we go. So the next page are the following solutions to the equation. And we learned in chapter 5 or module 5, solutions mean, do they make the equation true? That was the definition of a solution. Value of the variable that makes the equation true. So how we test that, we don't draw a graph. We just put first coordinate is x, 1 in for x, and negative 3 in for y. And then we work that out and see if that gives us 5. So 2 times 1 minus, and you can't ever have two signs side by side. If you have two signs side by side, which we do, we have the subtraction, and then we're plugging in a negative 3. The second one always has to be in parentheses. And we want to know, does that give us 5? 2 times 1, double negative, we know is always positive, so we make a big plus sign, just like we did when we were doing division. 2 negatives made a big plus. So is 2 plus 3 equal to 5? Yes, it is. So that means yes, it's a solution. Okay, now we do the same thing with the next point. X is 2 this time, and y is 1. So 2 times 2 minus 1, is that equal to 5? And 4 minus 1 does not equal 5, because that is 3. So we would write not a solution. So there's two things I want you to know about this. Not being a solution means, and we're going to learn this as a line, means this point is not on the line. Being a solution means when I learn to draw this line, which we are going to in the next page, that point will be on the line. That's what a solution means when you're graphing lines. It's a point that will be on the line. So if we were to draw the line, this point would be on it. If we were to draw the line, this point would be somewhere off the line. So that's the difference between yes, it's a solution, no, it's not a solution. It's a point on the graph, but it's not on the line. It's important that you understand what that means when you have an X and a Y. The point will not be on the line when we draw it. 2.5, 0. Ooh, this is a good one because it's something I haven't showed you yet on the calculator. 2 times 2.5. Y is 0 minus 0. Is that going to be 5? So, doing mixed numbers on the calculator is a little bit of a learning curve, so we'll pay attention so you know this for the test. So when I plug it in, and most of you can do this in your head, 2.5 doubled is 5, but I just want to show you how to do it on the calculator if the number was too big. So you do 2 times, and to type in a mixed number, you have to hit the fraction bar twice. You go 2 fraction bar 1 fraction bar 2. So that's how 2.5 looks. And students go, well, why do you need that 1 here? Well, it would be 21 without it. So you have to tell the calculator there's a space there. So it's 2 space and then 1/2. So that's how you type in a mixed number. You hit the fraction bar twice. And then -0, is that equal to 5? Yep, it is. So yes, it's a solution, which also means it will be a point on that line when we learn how to graph it on the next page. Oh, I gotta put an exclamation point. Okay, so that's how we check for solutions when we have 2 variables, an x and a y. You plug the first one in for x, the second one in for y. True statement, it's a solution. False statement, it's not a solution. And next we have, just get a paper clip because my papers are slipping. Complete each order pair. And this, all 3 of these, or all 4 of these on this page are all pretty much the same. On this one, they gave us x. So that means we need to find y. So we put 0 in for x, and we write our new equation. 0 plus 2y equals 8. So this isn't a yes or no question. This is find the missing part of the order pair. So in this one we're finding y, this one we're finding x, this one we're finding y. So 0 plus 2y is 2y, and then we just solve the equation like we learned in Module 5. Do the opposite of times, which is divide, y equals 4. So there you go. There's my completed ordered pair. So now that will be a solution. If you plug the points in, 0 plus 2 times 4 is 8, 0 plus 8 equals 8. So we're making the points so that they are solutions or points on that line. Next we have y is 3. So we write x plus 2 times 3 equals 8. And again, we're not doing a true or false statement. We're solving the equation for whatever letter is there, either x or y. So x we don't know, so we leave it x. Y we put in as 3. So x plus 6 equals 8. Oh, why weren't the equations this easy in chapter 5? X equals 2. So you still do the same thing, do the opposite. Opposite of times, divide. Opposite of add, subtract. And there we have it. There is our order pair, which is now a solution. And the cool thing is you can just check it in your head. 2 plus 6, yep, that's 8. So very easy to check. I love it when we can check equations. It makes the work so much easier because you can walk away and go, yes, I know I got this one right. Next we have x is -5. So -5 plus 2y equals 8. So in order to get y alone, we have to do the opposite, which is add 5, because we need anything without a variable over on the right side. And then we get 2y equals 13. Divide by 2, divide by 2. Y is 13 halves. And if they don't tell you to write it as a decimal, don't, just keep it. So 13 halves is our y. Now if you were going to graph that, you would write it as a decimal at 6.5. So you would find the point -5 on the x-axis, 6.5 on the y-axis. But if the directions don't tell you to turn it to a decimal, we just leave it as a fraction. And many times, Alex will say, write your answer as a simplified fraction or as a decimal. So you just have to do whatever the directions say. This one doesn't have directions, so I just left it as is. The less work you do, the better, because the less chance you have for making an error. Okay, the next two are exactly the same thing, except they're giving us a t-table. So on this first one, you'll put -3 in for x, find y. The next one, you'll put 0 in for y, find x. 10 in for y, find x. And then same thing here, so you might have to use your calculator a little bit, but I want you to try these two on your own, since we just did 1, 2, 3, 4, 5, 6 examples above. So go ahead and shut off your video, work those two out, and remember, it's okay to make mistakes. Don't worry about being a perfectionist. Just do them the best you can, and then if you have to correct them later when we go over it, no problem. So go ahead and do those two and then come back and check them. For this first one, x is -3. So y equals -2 times -3. Remember how I said when they're negatives, you have to put them in parentheses so that you don't accidentally mix up and think it's subtraction. So we can see a negative times a negative, +6. First one's done. On the next one, y is 0. So we get 0 equals -2x. So the first thing I do is turn it around, because the letter I'm solving for, I always want on the left. And then I solve just like normal. For some reason, students freak out when they see 0. You work 0 just like you do any other number. Just solve the equation, write the answer. The opposite of times -2 is divide by -2. And we get x equals 0 divided by anything is 0. And if you're not sure about it, that's why you have a calculator. 0 divided by -2. So don't use the fraction bar, because remember, negatives can't go in the denominator. You have to use the division sign, and it will tell you, yep, it's 0. And so x is 0 for that one. And remember, we're making solutions. So all these points we're finding are going to be on this graph when we learn how to graph it on the next page. Okay, last but not least, y is 10. Ooh, that's convenient. Just add a 1 there. So we get 10 equals -2x. I'm going to flip it around so there aren't any errors here. Opposite of times -2. Divide by -2, and I get x equals -5. So you just plug in the value they've given you and solve for the value that you don't know. They gave me y's here, I solve for x. They gave me the x here, I solve for y. So everybody do okay on that one? That one was pretty easy, huh? Okay, on example 6, x is -3. And remember, when you plug in a negative, it must be in parentheses. So y equals 1/3 parentheses -3. And that just means 1/3 times -3. And then -1. So this one, we just have to put in our calculator, just like we see it. 1 fraction bar 3 parentheses, and then this is negative, so use your -3 down here, not your subtraction sign. So 1/3 parentheses -3. Now this is subtraction. Subtract 1, and that tells me y is -2. Next one, we have x is 0. So that's going to be an easy one. 1/3 times 0 minus 1. Anything times 0 is 0, and if you're not sure, Don't guess, especially when you're on a test. 1/3 times 0, it will tell you that's 0. So y equals 0 minus 1. If you have 0 minus 1 is -1. That means start at 0 and go left 1, and you end up at -1. And probably this third one's the hardest one for students. So now y is 0. And I think it's because they already have forgotten what we learned in chapter 5 or module 5. So flip it around and do it just like you did all the module 5 problems on your last test. So I need to get x alone, add 1, 1/3 x equals 1, and then we learned that whenever you have a fraction, multiply both sides by the LCM, which this case there's only one denominator, so the LCM has to be 3. Or you could think of it this way: what's the opposite of divide by 3? Multiply by 3. But whatever you do to the left, you must also do to the right. And that's the whole reason we did that, was to get rid of that fraction. So now on the left we just have 1x, which is x. So x equals 3. Beautiful, right? So all that stuff we learned in module 5 is not going away. We still use it a lot, especially the fraction stuff we learned. Okay, let's move on to page 3. So now we're going to learn about the lines. So anytime an equation can be written in the form y equals mx plus b, that means it's going to graph as a line, and it's called a linear equation. So every equation that looks like y equals mx plus b, y equals 3x plus 0, y equals 3x minus 2, y equals 2/3 x plus 4, they're all in this form. Like this one, you have to add a 0, of course. Okay. So m, we're going to learn, is called the slope. And we refer to that as the rise over run. We'll see on the next page, that's the definition of slope, or not the next page, in one of the next lessons, that it's slope is just rise over run. It's how fast the graph goes up. So the letter in front, or the number in front of x is called the slope. B, we're going to learn, is the y-intercept. 0b is the y-intercept. It's where the graph crosses the x-axis. And we talk about this way, way, way more in depth. Right now, they just want you to practice identifying them. So the number in front of x is called m, or the slope. And the reason it's m is because it was a French mathematician, Descartes, who came up with the concept of slope, and he was talking about montañas. So that's m is why he chose slope, because he was talking about how steep it is, and that is m. And then 0 comma b, remember how we said on the last page the y-intercept always has x0, so 0 comma whatever right there is called the y-intercept. So like I said, we're not doing anything with those right now except identifying them, but the more you see this, the easier it will be to remember it, so that's why I introduced it now. So the number in front of the x is the slope, 3, and if there's no number out at the back, you can add 0. So my y-intercept as a point would be 0, 0, but this one just wants b. It doesn't want the y-intercept. But you would put it right there if you were finding the y-intercept. So it would be 0, 0, which means this line goes through the origin. And you know what? I know we talked about it in lesson 1, but I forgot to mention that again here. So if you can go back to page 1, that point where the two axes meet, its coordinates are 0, 0. And in lesson 1, we wrote down that it was origin, but it's nice to have it all here as well. Okay. So you can make a note of that, even though we talked about it previously. On this one, the slope is always what's in front of the x, so that's 3. And then b is what's out back, so you have to take its sign and the number, so it'd be -2. So I know this line is going to cross through the y-axis at 0, -2. This one, the m, is what's in front of the x, 2/3, and remember it's rise over run. And the b is 4, so this graph crosses the y-axis at 0, 4. So we know how to identify m and b. Now we're going to look and see which of these equations could be written as y equals mx plus b. So this one, I could bring the x over, right? And then divide everything by 2/7. So this one can be written as y equals mx plus b, and this is the standard form. So if it's either of these forms, x plus y equals number, or y equals mx plus b, they graph as lines. And this is x plus y equals a number. So yes, that is a linear equation. So that would be yes, it's a line. It will graph as a line. So on B, this is what disqualifies it. Anytime there's a squared, x is squared, it's actually going to be a parabola. That's what you study in the next class after this one. We study lines. In the next class, you study parabolas. So anytime the highest power is 2 and it's on the x, it's going to be a parabola. This actually, parabola is going to cup down, which you don't need to know. But when I subtract x squared over to solve for y, it'd be y equals -x squared plus 8. When there's a negative in front of the x squared, it cups down. So this is not a line. And if you want to just store away in your vocabulary, this would be a parabola. So lines can't have any turns. They're straight and go on forever in both directions. This one would graph as cup-shaped. So I come to this one, I go, ooh, could I make this y equals mx plus b? Oh, sure I could. Isn't this the same thing as that? Y equals mx plus b, because 0 times anything is 0. So 0 plus 12 is still 12. So this is a line with slope 0, and we're going to learn that means it's a horizontal line. So we'll learn all that in this chapter, but right now you just need to know that it can be written as y equals mx plus b, so therefore it is a line. And this one can also divide both sides by 3, and you get y equals -5/3 x plus 0. So yep, this one can be written too. Basically, the moral of the story is there can't be any exponents. If there's exponents, it's not going to be a line. If there are no exponents, which actually there are, there are only one, but if the highest exponent is 1 and the x's and y's aren't multiplied together, then it's a line. And you could also make this one look like standard form. Add 3y over to the left and you get 5x plus 3y equals 0. So it can be put in standard form, and it could be put in y equals mx plus b form. So we're going to learn two different ways of graphing. The first way we're going to learn is making a t-table. And sometimes on the tests they're going to ask you to make a t-table. Sometimes they won't give you a t-table and they're just going to say graph. That means you'll use another method. So anytime they give us a t-table, we fill in the x values. So 1, 2, 3, 4, 5. So -2, -1, 0, 1, 2. Why did I pick those values? Well, the general guideline is whenever you're graphing, you should pick 2 negatives, a 0, and 2 positives. So I need these points to stay on the graph. That's why I picked the smallest ones possible. Because yeah, you could have picked -10, but you're not going to find -39 on the graph. So those are usually what we call the standard t-table if there aren't any fractions, and we just stick with those x values. And then you just evaluate like we did on the last page. Y equals 4, in place of x, put -2, and it must be in parentheses, plus 1. And then you do y equals 4 times -1, in place of x, plus 1. I like to write them all out and then work them. Y equals 4 times 0, plus 1. Y equals 4 times 1 plus 1. And now put 2 in for x. Y equals 4 times 2 plus 1. And so you can do them on your calculator in your head. You know, if you're kind of sketchy with adding in your head, do it on your calculator. -8 plus 1 is -7. -4 plus 1 is -3. 0 plus 1 is 1. 4 plus 1 is 5. 8 plus 1 is 9. And one thing you'll notice about lines, they have a constant rate of change. So as long as these are all in a row, you should be adding the same thing to get the next number. And on this one, it is add 4. -7 plus 4 is -3. -3 plus 4 is 1. 1 plus 4 is 5. 5 plus 4 is 9. So that's what we call a constant rate of change. It's actually the slope of the line. But you can kind of tell if your table's correct by seeing if all, and these have to be in order for this to be true. If you did -3, -1, 0, 1, 2, they wouldn't be in order. So these are all right in a row, so we can see that add 4 to get the next number, add 4 to get the next, add 4 to get the next, add 4 to get the next. So that's called a constant rate of change, which we're later going to learn is a slope, and we can see the slope is indeed 4 here. To graph a line, sketch the line, we just plot the points, and then we use a straight edge to connect it into a nice straight line with arrows on both ends. Lines do go on forever, both directions. So x is -2, y is -7. X is -1, y is -3. X is 0, y is 1. X is 1, y is 5. X is 2, y is 9. And what I want you to notice is rise 4, run 1. Rise 4, run 1. Rise 4, run 1. Rise 4, run 1. So to get each successive point, we're just doing the slope. Rise over run. The slope is 4. So if we put that over 1, just rise 4, run 1. Rise 4, run 1. Rise 4, run 1. So those are some things you're going to see we're going to apply later in this module. So I'm just trying to point them out so you're aware of that. And you'll always know if you've graphed them correctly. One, they'll all have the same rise and run between the points. That's why I always pick my points in order. And two, the line will be straight. If you have a point out here, you did something wrong. So you'll always know if you did something wrong because your points won't line up. If it's in the form y equals mx plus b, it will be a perfectly straight line that goes forever in both directions. And I know many teachers who will take points off if you don't put arrows on both ends. And you'll see why that's important when we get into domain and range, when we start studying functions, because we need to know it goes down forever and up forever, and it goes left forever and right forever. So arrows are not optional. Lines go forever in both directions. So that's not so bad, right? We're going to learn a little faster method later on in this chapter, but this is tried and true. It's really hard to miss a problem when you use a table. It might take a little bit longer, but like I said, pretty hard to miss it. Okay, we have 2 more to do, because the next video starts on example 5. So we have, and I'm going to start you on example 3 and do it with you, and then I'm going to have you pick up from there. So whenever you're doing a table, you always want your line to be in y equals mx plus b. It's very difficult to do a table if it's not. Well, this is where chapter 5 comes into play. We know how to solve for variables, right? So if we take negative 2x plus 4y equals 8, we want to solve for y. That means y needs to be all alone on the left-hand side. So what I always tell students when they're first learning this is I say cover up the y. You don't want to move that. You need that to be alone on the left. So you do the oh, my pin's rolling. So you do the opposite to move anything else to the other side. So I want to add 2x, add 2x. So add 2x to this side, add 2x to this side. And why are we doing that? Because we need y alone to make a table. So now we almost have it alone. We just got to get rid of that 4. And we need our x first. So with its sign, move it first, 2x. And then 8 doesn't have a sign, so that means it's plus 8. So when you switch that order, make sure you keep the signs with it. The 2x is positive, the 8's positive. Because I'll have students have 8 and minus 2x here, and then they write 2x minus 8. No, the negative stays with the 2x if it's negative, and the 8 stays positive. So be careful when you switch that order to keep the sign with it. Next, we have to divide every single term by 4. So we're doing all the same stuff we did in Module 5. To get a letter alone, usually it was x for us, but now it's y because of this formula. We need to do the opposite to move everything else to the other side. So 2x plus 8, divide by 4, divide by 4, divide by 4. And remember, every fraction you have for the rest of your life needs to be simplified. So 2/4 have 2 in common. So when I write that in simplest form, it's going to be y equals 2 divided by 2 is 1. 4 divided by 2 is 2. So that's going to be 1/2 x plus 8 divided by 4 is just 2. So make sure all your fractions are simplified. Both of these can simplify. This one, divide them both by 2, get 1/2. This one, you just do division. 8 divided by 4 is 2. So there is my equation. So notice, and actually, do you know what? I'm going to do this one completely with you. I'll let you do the next one because you haven't done a fraction yet, and I need to show you how to pick the values carefully. So whatever the denominator of the fraction is, everything in this column needs to be multiples of that denominator. So I don't want to pick -2, -1. -1, 2 doesn't go into it. So I pick numbers that 2 go into. 2 goes into 0, 2 goes into 2, 2 goes into 4. So my table is -4, -2, 0, 2, 4. And if I don't pick that, I end up with fractions, and Alex won't let you graph fractions. So you have to make sure they come out whole numbers, and you do that by making sure all the numbers in your X column are divisible by 2. Yes, 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 yes. All are divisible by 2. So when you do this next one on your own, you got to make sure all your X's are divisible by 3. Okay, so that's the only time you steer away from -2, -1, 0, 1, 2, like we did on the last problem, is when you have a fraction, you pick multiples of the denominator. Multiples mean 2 times 0, 0, 2 times 1, 2, 2 times 2, 4. So now we can get it ready for the calculator. 1/2 times -4, which needs a parenthesis, because it's negative, plus 2, and we'll get them all ready for the calculator. 1/2, put -2 in, add 2. 1/2, now we don't need parentheses because it's no longer negative, so you can say multiplied by 0 plus 2. 1/2 multiplied by 2 plus 2. So I'm just rewriting this equation with my 5x values in. 1/2, in place of x, put 4 times 4 plus 2. And then it's all ready for the calculator, and you can just plug it right in and get your y values. So these are all the y's. Y equals, y equals, y equals, y equals, y equals. So we have 1 fraction bar 2, parentheses negative down at the bottom of your screen, 4, it's not a subtraction, plus 2, and that is 0. And then remember that trick I showed you with the calculator, where you can hit the up arrow, and I don't have to type it again. I can just go on top of the 4 and make it a 2. And I don't even have to key to the end of the problem. I can immediately go to enter. And that one's 1. This one we can do in our head. 0, because anything times 0 is 0. 0 plus 2 is 2. Or you can do it on your calculator. So I'm going to show you another trick. So pay attention here. Up arrow. I need my x to be 2, not -2. So you key over to the negative and you hit DEL. And there it is. 1/2 times 2 plus 2. And that's why I always start with negatives, because it's really easy to delete, not so easy to insert. So I always start with negatives on my t-table for that reason. Hit enter, 3. And last but not least, up arrow and change your 2 to 4. And that is 4. And we can see the pattern that I told you will always be there. Add 1, add 1, add 1, add 1. There we go. So now we're ready to graph. -4, 0 would be on the x-axis. That means it's, okay, talk Kim. It's on the x-axis. That means it's the x-intercept, because y is always 0 on the x-intercept. And I can tell this is the y-intercept because on the y-intercept, x is always 0. So this will be on the x-axis. This will be on the y-axis. -2 up to 1. 0 up to 2. There's my y-intercept. 2 up to 3. And last but not least, x is 4, y is 4. And look at that nice, pretty line. And does everybody agree our slope is 1/2? And remember, it's rise over run. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. So every point has the same slope in between, and that's why it's called a constant rate of change. Okay, so last, get out your straight edge. Draw a nice straight line with arrows on both ends. And that is called graphing a line or sketching a line. So next, I want you to do this last one all by yourself. So remember, you're picking multiples of 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. So you should only have 0s, 3s, and 6s in your table. So go ahead and turn off your video. Fill in your x values. Then write your equation out here to the side. And plug it in your calculator to find your y's. Okay, let's see how you did. So did you guys pick -6, -3, 0, 3, 6? I mean, you could have picked other multiples of 3, but 9 and -9 would work. They're on the graph, but nothing bigger than that. So if you had -9 instead of -6, that's fine. But these are the easiest ones. They're the smallest, and each one's 3 larger, so that will make this be a pattern. So next you write out your work. 1/3 parentheses, -6, because I'm plugging in a negative, subtract 4. 1/3 in parentheses, -3, subtract 4. Now we can drop the parentheses. We're done with the negatives. So 1/3 times 0 minus 4. 1/3 times 3 minus 4. And last but not least, put your 6 in. 1/3 times 6. And this is when I really love my calculator, when I don't have to type it 5 times. All I have to do is change one number. So we have, ooh, I'm kind of in the, okay, now I'm out of it. So 1 fraction bar 3, parentheses, negative, bottom of your calculator, 6, close your parentheses, subtract 4. And that is a subtraction in front of the 4. This is a negative, this is subtraction. And that gives me -6. So notice I'm not getting any fractions, and that's because I picked multiples of the denominator. Then I hit my up arrow and turn the 6 into a 3. Hit enter, -5. Then I hit my, oh, this one we can do in our head. 1/3 times 0 is 0. Minus 4, -4. Then I can hit my up arrow, and this time I need to delete the negative. So go over there on top of the negative and hit DEL, delete, enter, -3. And last but not least, type 6 in over 3, and that gives us -2. And again, we can tell we did it right. Add 1, add 1, add 1, add 1. We have a pattern. The pattern will always be there if these are also in a pattern. And that's how you can kind of check your work. So -6, -6, oops, right here. -3 on the x, -5 on the y. 0 on the x, -4 on the y. 3 on the x, -3 on the y. And 6 on the x, -2 on the y. And we can also check it by saying, well, my slope is 1/3, which is rise 1, run 3. 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 And we could make more points just following that pattern, but we don't need any more than that. And so last, you will draw your line with arrows on both ends. And the next video starts on example 5, so we'll stop right there. See you later.